Hi there. Today I'd like to talk about bees or beetle. I guess we'll go with the beetle because it's a lot easier to draw. Um, Now the thing about a beetle is when you look at it, it's really kind of like awkward. I mean, I don't know if you've ever had to stop when you're watching, but you're like, how is that weird beast of a creature flying around? And your intuition, if you've had that thought, is actually quite keen because if you look at them aerodynamically, I guess some physicists or perhaps grad students or bachelor, whatever, have kind of looked into that and they're like, these guys shouldn't be able to fly. Which again, if you just are an observant person, you might have queried sometime, perhaps when you're a kid and you simply forgot about it. Hey Dad, why can beetles fly? Well, I asked a lot of questions like that when I was a kid anyway. So I'm going to put together a few things that perhaps are not new by themselves, but together might be some food for thought. Now there's an interesting myth here. I say myth simply because I have not verified it myself. That if you take a bunch of these wings of these beetles and stick them in a sack or a tube or some type of thing that's fairly light, that you'll actually get upward motion. Now, like I said, as of now, that's kind of an out there idea, right? But that's just very interesting to think. Because these guys need some help somehow or another. So a way to do that would be simply to reduce the organic matter in these wings and chemically assay them to determine their constitutes. And if you're looking for monoatomic elements, which is what I would be looking for because they do have this ability to resist certain magnetic fields and such, which is important because there has to be some type of effect going on here other than simple lift and aerodynamics. Well, such effects are exhibited by such materials at room temperature. Now, they're often exhibited by materials that are not at room temperature, such as your classical superconductor that's been lowered to the near theoretical limit of absolute zero. And this material then has an external magnetic field around it, which is quite strong and resists other magnetic fields, such that if you were to take an external magnet of some type and introduce it to this field, or try to, you would have resistance. There would be a barrier. You can think of this as a very homogeneous tribe, if you will, and this is an outsider. So there's resistance to his inclusion in the group. Now, like I said, most common, except for perhaps some ceramics nowadays and things they're working on, these materials are just certain types of metals, magnetic properties that are lowered very, very low. And what happens is, whether you think of these things as atoms or perhaps energy patterns or a little fluffy, daydreamy quantity clouds. Either way, these things, these minute structures, if you will, they sort of start exhibiting a group cohesion. They all start wearing the same hats, listening to the same music, and eating the same foods. And then their little dance together is what gives you the phenomenon of strong magnetic fields, sure, but also a flow of superconductivity, these little electrons form a sea, so to speak, that's sort of uniform, and you get a fairly lossless, ideally lossless environment for the transfer of electricity. Now, that's all cool, but a thing that's important here is that these little electrons actually exhibit a rather weird property, whereas the temperature is lowered, or as something is introduced to the field, which I guess then the density of these electrons will actually increase. So now we're talking about energy density being associated with sort of this magnetic state. Alright, and the thing about that is, like, my guess, and I have a guess because right now people are guessing, is that perhaps, it's just because in this certain environment here that these behave in a certain way because they're in a certain amount of energy pattern, like they're synced a certain way, and about the only way we know if something is something is that energy, that we see working with it. In other words, like, this thing's heavy, so it's exerting a certain force on something else, or this thing has so much density, so it's resisting your acceleration, or whatever it is. The nitty-gritty of mass is kind of currently not so substantial. It's like a breakfast of grits missing the eggs or something, and no bacon. So you have that going on, right? Which is interesting, because now we have a sort of a gross macro sort of phenomenon going on here with the energy density and whatnot. What's interesting is that these monatomic elements, like I was saying, if they're in the swing, but even when they're not, when isolated, they exhibit this thing where if they're in a test tube or something, and you just have a little hand, excuse my drawing here, they'll actually do this thing where they'll, like, jump away from your hand. There's certain YouTube videos on this, but yeah, you kind of have to get into monatomic elements and ORMUS to have those pop up in your awareness. Alright, and what's this going on here? I guess there's some magical thing, or is it that around this human there's a certain magnetic field, and this element, whether it's diatomic or atomic, iridium or plutonium or gold or whatever it is, will exhibit that behavior. Now, the interesting thing, though, we were talking about lossless conductivity, magnetic properties and whatnot of the conductors. This one happens to be a room temperature. This one is artificial, if you will. But the thing with them is you can't just stop there, because all this is possible. Like, you can't have electricity, superconductor, conductor. You can't have electricity unless you have a magnetic field for it to exist in and flow in. In other words, you could say, in a certain perspective, you can't have the electricity without the right electron configuration or flow or state, which is why metals and things like that, which have certain electrons, are good for certain applications or exhibit certain behavior. All right. But again, so you can't have the electricity without magnetism, and I think you can't have magnetism without sound. Which is interesting, right? Because